Okay, I'm going to tell you what is the significance of definite integration. For example, when I asked you a question of what is the significance of differentiation, what will you tell? To find the slope of a tangent to a curve at a given point. Similarly, there is a meaning of this definite integration as well. I'll tell you what it means. Suppose I take a function to be like this, some random function. So I take this is y is equal to f of x. Let me take a limit here as a and let me take the limit here as b. These limits corresponding to the x coordinate. Okay, I'll take this as a comma 0 and let this be b comma 0 so that you will understand it better. Am I clear with this? Now, if I drop a perpendicular from here and let me call it as some x. Okay, let me call it as some x. Now, I'll take another point which is very close to this point, so that I take that point to be x plus h comma 0. Okay, to be more specific, I'll take it as x plus dx comma 0, x plus dx comma 0, where dx is this distance, which is a very small value. Okay, now if I take this box, then what shape does this box take? It looks like a trapezium, right? But it can be approximated to a rectangle because these 2 points are very close to each other, so that this height and this height are the same. Am I clear with this? So this curvature is ignored because of the distance between these two verticals. So if this is x, what would be the corresponding point here? So what would be the corresponding point here? Is it not going to be x comma f of x? You take this x and substitute it here. It is going to be x comma f of x, right? So how much is this height? It is going to be f of x. Now, if I ask you what is the area of shaded rectangle, what is going to be the area of the shaded rectangle? What is the area of shaded rectangle? So it is basically this thickness. So how much is this thickness? This point is x comma 0. This point is x plus dx comma 0. So what is the difference between these 2 points? So this difference is going to be dx. It is only that much thick, right? Dx is a very small quantity, right? So area of the shaded rectangle is equal to f of x into dx. Can I write it like that? F of x into dx, right? Now, how many such rectangles of this small quantity can I find between the points A and B? So how many can I find? Balaji, are you there?
Yes, sir.
Okay.
Just one more request. I'm not seeing what you're pointing towards, sir, when you're showing it at the board, because it doesn't appear on screen.
Why is it so? I've switched on my video, no? Now are you able? Now
Yeah, sir. Now it's visible.
see, listen. So now is it clear f of x into dx? Like this, how many such thinnest rectangles you can find between A and B? You're going to have infinite such, right? So listen to this carefully. In your lower grades, you would have learned something like this. You will use sigma when the data is discrete. Where do you use the sigma? In statistics. So in statistics, how is the data taken? Like for example, x1, x2, x3, all these data are discrete data, right? So you will use sigma xi where I is varying from 1 to n, right, like this. So what is the meaning of this? You will have x1 plus x2 plus so on till xn. So what is that you are able to observe from this? Sigma I is equal to 1. What is this basically? This is the lower limit and I is equal to n is the upper limit, right? I is equal to 1 to n x of I, where xi is the variable, where xi is the variable. This is equal to sum of all these values. Am I clear with this? Now what you are going to do is, you will use a sigma when you have discrete data in your hand, whereas here you have continuous data, meaning you have infinite such rectangles which are attached to each other. So whenever you have continuous values, then to find the area made by curve, so area made by curve with x-axis, you write it like this. The sigma is replaced with the symbol of integration because you are adding. Integral of this area, okay, like integral of all these small areas between which 2 points? Between the points A to B. So when you do definite integration, what is that we are actually obtaining? We are actually obtaining the area made by the curve with the x-axis. So to be more specific, it is not always necessary that the area is calculated only with x-axis. To be more specific, I would say area made by the curve with the independent axis. So how to find that independent axis is, look at the variable that is there within f and look at the variable with respect to which you are integrating. So if you do a to b integral of f of x dx, and this is what is going to be called as definite integration. Am I clear with this point? Am I clear with this point? So now make a note of this. Yeah.
I didn't understand the part when you related sigma or you change sigma to the integral. Sir.
See, sigma is used when you have discrete values.
Okay.
Integration is used when you have continuous values.